Alright, so a vector has magnitude and direction. A scalar just has magnitude. Vectors are represented by like a ray. It has initial point and a terminal point. It's represented by that arrow. Alright. You see a lot of this in physics when you're drawing like force, representing force, movement of force. In a vector, and hadn't y'all started seeing a lot of vector on the ACT? More vectors? Yes. By the end of this unit, you'll be able to handle it. The initial point is located right here. The arrow is the terminal point. This is known as the tail of the vector. This is known as the head of the vector. Okay, so you need to know that this is referred to as initial point, tail, terminal point, head. Okay, we're going to be calling it tail and heads. Okay, because you got to draw them. You got to start at a certain point. Okay, you can name them two different ways. They usually have capital letters at the beginning and the end, and that be referred to as PQ with a line with a little. It doesn't have the arrow down here. It just has it up here. Does everybody see that? Or there's usually sometimes there's a lowercase letter that sits in the middle of it. You can either name it this way or put the lowercase letter with the same notation right there. So either way is acceptable. And I'm going to go tell you, you see how this point is sometimes right here at the end of this arrow? You're not always going to see it. Most time when I took science classes, it was just from the point at the beginning, the arrow represented the last part. Does that make sense? So you can see it either way. Are there any questions so far? Okay, so let's look at this. Let's determine this. Vector or scalar. A car traveling 60 miles per hour, 15 degrees east of south. Would that be considered vector or scalar? Vector, because there's your magnitude, there's your direction, okay? Number 2, wind blowing at 30 knots. Scalar, because it tells you the direction. Do you see the difference there? Okay. Alright. Now, let's talk about some different forms over here. Component form. This is very important to know what component form means, okay? Component form. Given this vector, your tail, your head, your initial, what's this called? Terminal. What's this called? Initial. This is called? This is called? Now use the other language. What's this called? Thank you. This is an important vocabulary word. I don't know why they call it this too, but this pretty much tells you the position. But as long as you know this word right here, component form. It is. Okay, when I say component form, what do you think I mean? Components. Okay, that's what I mean by the components. The horizontal and vertical components of that vector. What does it take to get from here to here using horizontal and vertical? Like how many spaces up and over, okay? That's what component means. And it's written like this. A number, comma, number. You find it by going x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. You're going to have to know that formula, okay? That's component form. That's talking about this is how many right or left you had to get to the other point and how many up or down you had to get. It's your horizontal and vertical component. Does that make sense? Like you starting at your tail, you got to get to your head. So it's like your direction. Okay. Now it can be in component form or it can be in what's called linear combination form. And that's AI plus BJ. The number right here in front of the I, there's always going to be an I there and there's always going to be a J there. The number in front of your I is your X component. And then the B is your Y component. The way I remember it is when you say your ABCs, A comes before B, just like X comes before Y. Okay? Yes?
That was the stuff I saw by ACT.
Yes.
That was like the easiest part.
Mm-hmm. But that is component form. We're going to be talking about component form and magnitude today. So that's the main things we're going to hit home today. Component form, magnitude. So does anybody understand how we find the component here? We're going to practice all this. I'm just giving you an overview right now. Now, when you draw vectors in the coordinate plane, the direction is your angle between your vector and your x-axis. Angle made with x-axis. Like I said, magnitude is the length of the vector, the size of the vector. Here's another formula you need to know. You need to know this formula today and this formula. The symbol for magnitude is like two lines here, the two lines over here. Equals the square root of a squared plus b squared. That's these values, okay? These values. So that is how you find the size of a vector, is by using the formula square root of a squared plus b squared. Alright, so the first part that we're going to look at in our note taker says state whether each quantity described is a vector or a scalar quantity. Number 1, a boat traveling 15 miles per hour. Parker, what would that be considered? What's my magnitude here, guys? 15. Do I have direction? So what is it? Scalar. We have magnitude. The boat's going 15, but we don't know what direction. Number 2. A hiker walking 25 paces due west. What's my magnitude here? 25. What's my direction? So what is it? Vector. Okay, this is a tricky one. A person's weight on a bathroom scale. Okay, think of the definition of weight. There's a difference between mass and weight. What's mass? The magnitude. What's weight? When what is calculated in there? Gravity. Gravity's going what? Down. That's the only one you got to think about. If it talks about weight, the force of gravity is pushing downward, so that counts as your direction. Okay? That's why I put this one on here. Because it was in the textbook and I went, oh, I need to go over that one. The only time you got to worry about that, and you don't see this one occur much, if it's talking about weight, that's a vector. Or let's say it's something, like I saw another example in the book, there's a swing hanging from a tree. Would gravity play a role in that? So anything hanging or the weight would be considered a vector, even though if you don't see the direction, because the force of gravity pushing downward, okay? Now you say, Mr. Fisher, okay, you can say, I push this box with a force of 25 newtons. Would that be vector scalar? That's scalar, okay? It's just, you got to worry about weight and hanging object because of gravity pushing down on it. If you're sliding something, you okay? Alright.
So if you said you were sliding the box a certain direction,
That it would be considered, if it said with a certain direction east, that would be a vector. If I just said I'm sliding a box with a force of 25 newtons or whatever, then that would be a scalar. But if I said 25 newtons west, it would be a vector. The only tricky one here is this one. Hey, if I say weight or something hanging, you got me? Those are your key words. Are we good on that? Okay. All right. The next part. It says write the following vectors in component form. So that's our first. We're going to look at our first two learning targets. It says I can write a vector in component form and determine the magnitude. So that's what we're about to do on these two problems. Is write it in component form and then determine the magnitude, okay? Alright, so on this first one, okay, your formula is x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. So here we go. So this will be 6 minus a negative 3, comma, 8 minus 5. That's a double negative, 9, comma, 3. So that would be component form. Now, I drew this vector out because I want you to understand truly what component form means. Okay, so I graph the 2 points, -3, 5, and 6, 8. Okay? This is what component form means. I'm going to try to get from my initial to my terminal, from my tail to my head of my vector. Watch this. 1, 2, 3. Do you see a 3 in your component form? Where's 3 sitting? First or second? That's in your Y spot, isn't it? Isn't vertical dealing with your Y axis? Okay? Now let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you see a 9 in your answer? Where's it sitting? First. That's your horizontal component. Do you see that? Okay? Yes.
So it's essentially your slope, but not surrounded by parentheses.
Mm-hmm. It says vector.
Yeah.
Symbols. Yes, and it's backwards. Like it's broken into your horizontal and then your vertical component.
Do we have to use little
Yes.
zeros?
Yes, where it's marked wrong. Yep. It has to look like that. The only time that you have to do AI plus BJ is if it tells you in the directions, which is the next part, okay? You have to, whatever form it tells you in your directions. Now, I want to find the magnitude of this vector. So the magnitude, you square both of these and add them together. So that's going to be 9 squared plus 3 squared. 81 plus 9 equals square root of 90. And that's broken down to 3 square root of 10. That's the length of that vector. 3 square root of 10. 90 is 9 times 10. You can bring it. No, it's the actual length of the vector. The length of that arrow.
Right, you got the 9, you got the 3, and that's not 5.
All right, number 5. Let's find the component form. 10 minus 4. 7 minus 9. I get 6 and negative 2. Okay, let's find the magnitude of that vector. Mason, can you see? Okay. 6 squared plus negative 2 squared. 36 plus 4, square root of 40, which would be 2 square root of 10. This is not bad, is it? This is better than last unit? Oh. You like this one better than last unit? The next part, our third learning target, is I can write a vector given magnitude and direction. Like you got to work backwards to find the components of it, okay? So I'm going to give you the magnitude, the length, and I'm going to give you the direction in the form of an angle, and you got to go backwards to find the component form. All right. It says write the vector in the form AI plus BJ. Okay, what form is that called? You need to know that. That's called component. We're going for linear combination. But don't we have to know the components to write the linear combination? Yes. Okay. So, here's the formula. Right here. To find your A, that first term, is the magnitude equals cosine of the angle. So you do not want to write that down. A is found by saying the magnitude times the cosine of the angle. That's the Greek letter alpha. You can put alpha or theta, whatever you want to do there. B is the magnitude times the sine of the angle. And the way I remember this, guys, isn't A your horizontal component? Isn't A your horizontal? What's horizontal component related to, X or Y? X. is cosine of your x or y value. So you see how cosine is in the A formula? Okay. B is related to your vertical component, which is your y component. Isn't sine your y component? That's how we remember that formula. Okay. All right. So on number 6, let's find our A and B. So 6 is A equals 5 times the cosine of 60. B is 5 times the sine of 60. So important to know your trig. Cosine of 60 is what? 1/2. Sine is square root of 3 over 2. So A equals 5/2. B equals 5 square root of 3 over 2. So once you have that, you write it in your linear combination. 5/2 I plus 5 square root of 3 over 2 J, and that's your answer. That's your linear combination. All right, let's look at number 7. A equals 14 times the cosine of 120. B equals 14 times the sine of 120. What does this symbol mean right here? Magnitude, that's the length of the vector. Do we understand that? The size. That is the angle it forms with the between the vector and the x-axis is 120. Okay? So A equals 14 cosine of 120. What is that? Positive or negative 1/2? Negative. It's in quadrant 2. Alright, so it'd be negative 7. 14 times the square root of 3 over 2. So B equals 7 square root of 3. So I would write that negative 7I plus 7 root 3J. Does it matter which one you put with I and J? Yes, it does. The I, just like A comes before B, I comes before J. I is your horizontal component, J is your vertical component. Yes?
So does I and J actually the second placeholder?
Placeholder. Yep. I just don't know what they just thought they want to have another form besides component, so they did linear combination. Why don't you do number 8 on your own right there? Do number 8. And then we'll really have to do something easy next. I got 25 root 3 over 2I minus 25 over 2J. Y'all agree with that? Now what we're about to talk about now is what you're seeing a lot more in the ACT. Is operations with vectors, and they're so easy. So easy. That's why I love this unit. There's two ways of doing operations with vectors. You have something called geometrically and algebraically. We're going to do algebraically today. I'm going to say geometrically for tomorrow. Geometrically involves literally drawing the vectors. Algebraically means just working it out, okay? That's how I remember. Geometrically you're drawing, algebraically you're working it. So let's look at, like I said, we're not doing this side today. We're going to do this side. Given a vector here, what form is that in? Component or linear combination? And it wants you to do 2 times the vector v. Well, there's vector v, isn't it? What do you think you just do? Multiply everything by what? There you go. That's your answer. Next, I have negative v. What do you think we just do? Multiply everything by what? Mm-hmm. Is that not easy? When you do something simple like that, when you're just multiplying a vector by a single digit, that's called scalar multiplication, okay? Just like matrices, like scalar multiplication, like you have a matrix times some number, same concept. Alright, let's look at this. We are given 2 vectors, vector v and vector w. We want to add that. So that's just 7i plus 3j plus 4i minus 5j.
11i minus 2.
Very good. You just combine what? Like terms. Now, if your vectors are given in linear form like this, then your answer needs to be in linear form. If your vectors are given in component, then your answer needs to be in component. Does that make sense? Okay. Here, would it be important to write this one out? Yes, because what's that minus going to do to everything? Change that sign in that second parentheses. It says to be 7i plus 3j minus 4i plus 5j. And then that will give me 3i plus 8j as my answer. So we're basically just adding, subtracting vectors. Okay, let's turn over. Let's do 13 and 14 first before we do 9 and 10, okay? Number 13. It says find each quantity if vector A, if A equals this and B equals that. What form are these given in? Component, aren't they? So my answer needs to be in what? Component. So watch this. I'm going to say 3 times vector A plus 2 times vector B and then what do you do from there? Just add your what? Corresponding parts. Aren't these at the A spot 9 and 4? So 9 and 4 gives me 13. Negative 6 and negative 2 gives me negative 8, and that's my answer. Nick, you like this? Or is this boring to you? Now I want to perform this operation. 2 times vector A minus vector B. What do you think that minus does to everything in that vector? What's that minus do to everything? Changes the signs. So I change it to a plus and change the signs. And that's my answer. Alright, going back to 9. It says find each quantity if vector v equals 3i minus 5j and w equals negative 2i plus 3j. What form are those vectors in? Linear. So in this section, your answer needs to be in component or linear form? Linear. Do y'all see that? Okay, so we got 2 times vector v plus 3 times vector w. Six I and negative 6i gives me 0. So negative 10j plus 9j would be negative j. If it's 0, you don't have to put it there. Alright. Number 10. 3 times 3i minus 5j minus 2 times negative 2i plus 3j. Distribute. Now let's look at number 11. Are there any questions on 9 and 10? Number 11 is a little bit different. What do you think 11 is saying to you? Yeah, so what would you do first? Find the magnitude or do what's inside? Very good. You're going to add v plus w and then find the magnitude of that, okay? So let's add v plus w. It's like order of operations. V plus W. So I got I minus 2j. Did y'all get that? I can do that fast. Is that what y'all got? Okay, now how do we find the magnitude of that? You take your first component and square it, and then add the second component and square it, okay? So I'm going to say square root of what? 1 squared plus plus what? Negative 2 squared. So that gives me what? Square root of? That's your magnitude. That's your answer to that particular problem. Okay, let's stop there for the day, but don't put your stuff up. As you can see tomorrow, geometrically, I give you the vectors here, and you've got to construct the answer to these problems. So that's tomorrow. Let's review. Vector has both what? Scalar just has what? If I ask you to put in component form, how do you find that? The vector symbols, what goes first? X sub 2 minus comma. Okay, very good. Okay, what is linear combination? AI plus. Very good. Okay, now you can write the name of a vector. Now, this is something I want to make sure. You have to start with the initial point and go with the terminal point, PQ. If you wrote QP, that is wrong. Okay? So you have to start with the tail and then the head. Okay? A car going 50 miles per hour. Vector or scalar? Scalar. A boat traveling 40 knots due west. Okay. A person's weight 180. What would that be considered? Vector. A person's mass. You see the difference there. The only time you got to worry about the weight is the force of gravity. All right. What is the definition for magnitude? Square root of what? Plus b squared. Very good. Now, if I give you magnitude and direction, you're going to work backwards for A and B. What's your A formula? Magnitude times cosine of the angle. What is B? Very good. You only have you get 6 problems. Make sure you learn this form tonight. Make sure you learn this form tonight. There's 6 problems. You come in not with 6 easy problems, I'm going to take you outside the hallway. Okay? Okay, I need a hand signal. We good with this first learning card. I can write a vector and component form. Let's do this quick. Okay? I can determine the magnitude of vector. I can write a vector given magnitude and direction. That means you got to find A and B. Okay, thank you.